In level 1, we will be reviewing 30, 60, 90 triangles and 45, 45, 90 triangles, and also determining the signs of the trig functions in given quadrants. And then also looking at applying periodic properties. 30, 60, 90, and 45, 45, 90 triangles are important for the ACT coming up. With 45, 45, 90 triangles, the two legs of the triangle are the same always, and the hypotenuse is whatever the leg is times the square root of 2. So in example A, when we have a hypotenuse of 7 radical 2, the legs would each be 7. In a 30, 60, 90 triangle, the shortest side across from the 30-degree angle we call x. And then if we double that side, we get the hypotenuse, which is across from the 90-degree angle. So we call that 2x. So for example, if this was 5, this would be 10. Just multiply by 2. And then the side across from the 60-degree angle, which is the longer leg of the triangle, is whatever that short leg was times the square root of 3. So if our shortest leg is 5, the longer leg would be 5 radical 3. Okay, so in example B, we know the hypotenuse. This is the side that we call 2x. So the short side, dividing that by 2, would be 6. And then this would be the 60-degree angle. Across from that, we take our short leg, 6, times the square root of 3. In this next example, we have a 45, 45, 90 triangle, and we're given the hypotenuse, and this is the side that we call x radical 2. So in this case, we need to set up a little equation. 14 equals x radical 2, and we need to solve for x, which would be the length of the two legs. So I divide this by radical 2, and x equals 14 over radical 2, but I can't leave a radical in the bottom, so I multiply by root 2 over root 2, and we get 14 radical 2 over 2, which simplifies to 7 radical 2. So these two sides, the legs of the triangle, would each be 7 radical 2. And in this last example, we are given the shortest side, which is across from the 30-degree angle. So that's our x. If we double that, we get the hypotenuse. So 2 times 5 radical 3 is 10 radical 3. And then for the longer leg, we take the short leg, 5 radical 3, and multiply by radical 3. So we get 5 radical 9, which is just 5 times 3, or 15. The other part of level 1 is determining the signs of various trig functions based on the quadrants that they're in. If we wanted to find the cosine, or the sine of cosine of 250 degrees, first I need to figure out which quadrant 250 degrees would terminate in. The initial side is always on the x-axis, and a 250 degree angle would be in quadrant 3, about right there. So since it terminates in quadrant 3, and cosine is x, cosine of an angle is x over r. R is always positive, and in quadrant 3 x is negative, so the sign would be negative. For tangent of negative 6 pi over 5, this angle would, we always start with our initial side on the x-axis. I'm going to swing down for a negative angle in this direction, and 5 pi over 5 would be equal to pi, and we're going to go a little further than that, so I would end up in quadrant 2. And if we want tangent of this angle, tangent of some angle is always y over x. And in quadrant 2, y is positive, x is negative, so tangent would come out negative. And for the last one, cosecant times cotangent in quadrant 4. So if I have an angle that terminates in quadrant 4, like this angle, cosecant theta is r over y. Cotangent theta is x over y. And in quadrant 4, y is negative. So cosecant theta would come out to be negative. R is positive always. And then cotangent theta, x is positive and y is negative, so this comes out to be negative. And if I multiplied cosecant theta times cotangent theta, I'm multiplying a negative times a negative, which would give me positive overall.